Thanks for your patience, everyone. I apologize. I'm working in the field today, setting up some monitoring systems for a customer, and like many an agricultural area, it's a little rural and the connectivity spotty. So thanks for bearing with me while I got everything online. So I want to go ahead and kick off here. This is the second webinar in our series focusing on how to succeed in a climate smart commodities program. This session is going to focus on measuring, monitoring, reporting, and verification, or MMRV, for climate smart commodities projects, and how it can take a coalition of groups to do that to a very high degree of success, and what we've done so far and what we're going to be doing going forward. So thanks for joining us today, and I'm looking forward to walking through these slides with you. So first up, please mute yourself unless you're speaking, and I'll try and do the same. There's some tractors operating in the vicinity, but they're not too close right now, thankfully. If you have any questions, please go ahead and throw them in the chat, and we will get to them at the end. And then finally, this will be a recorded call, and we will send out the recording along with the contact information for all participants if you have follow-up questions. All right, now I'll run on to some introductions here. I'm Adam Keppel. I'm the co-founder and CEO of Agrology, and we are here to help provide on-the-ground ground truth measurements for this project. Josh, go ahead.
Yep, my name is Josh Perlman. I am the CEO of Praedictus. Our role in this project is twofold. First, Praedictus as a company, our core competency is biophysical crop modeling. So we are providing biophysical crop modeling for the forage systems that we're looking at in Florida and Puerto Rico. And we're also serving sort of as the general manager for the MMRV component of this project.
Awesome. I'm Dominic Sutton-Vermeulen. I'm the CEO of MillPont. We are a claims clearinghouse and data cooperative. We are providing digital infrastructure to help create environmental assets from the MMRV data and the stewardship practices implemented by the farm partners.
And then additionally, I want to take a second here to introduce, or to allow them to the folks to introduce the people who are leading this project overall. And so if we could start off with you, Jose, please, that'd be great.
Yeah, good afternoon, everybody, and thank you for inviting us again here. My name is Jose Sanchez. I'm the Executive Director of Hispanic Climate Smart Commodities Initiative. Our role as Victus Puerto Rico is oversee this Climate Smart Commodities initiative in Puerto Rico and Florida.
Thank you.
Happy to go.
No, if you may be.
That's Nolo Martinez. I'm calling from North Carolina, even though I'm a big supporter of the Orioles. Apologize for my attire, but anyway, we are focused on data. We're also focused on intel on the ground, beyond the data, with the farmers, the landowners. We are also leading efforts of outreach in Florida, and big supporters of minority farmers throughout the U.S. Thank you. Great to be here.
Thank you.
Good afternoon, everyone. Francisco Martinez Oronoz here, CEO of Concentrico. We are a social impact consulting group out of San Juan, Puerto Rico. Our role in all of this is the coordination, strategy, and the compliance with everything that the Climate Smart Commodities grants entail. So pleasure to be here.
Thank you. And was Edwin unavailable, or Edwin, are you there?
I don't believe he's been able to join, but I can support
so finally,
here.
That'd be great, please.
Yeah, sure. Edwin is leading everything that is related to our curriculum and materials. He has a long career working with the NRCS in the implementation of of climate smart practices and working with producers in and outside of Puerto Rico.
All right, thank you. So first off, I want to lead with a brief introduction to the measurement approaches that we're looking for on this project. So to start off with, there's a variety of things that are considered ground truth measurement. And then there's other things that can be done that can kind of approximate. And so I think it's important to consider that there's a significant difference between these things, but all of them have a role in a Climate Smart Commodities project and the MMRV component of it. What I would emphasize is that the foundation of any Climate Smart project MMRV program should be ground truth data. Without that, you're not measuring, you're just kind of guessing and estimating. So first off, soil testing is one of the most widely used approaches to MMRV. It'll let you take a look at changes in soil carbon primarily. And that's extremely valuable both to understand how the project is affecting carbon storage in the soil, but then also can provide high quality information for the farmers who are participating to help them understand how the changes in the soil are benefiting their agricultural system. Next up is remote sensing. And remote sensing uses data feeds typically that are from publicly run satellites that can provide some information potentially on soil conditions or on the growth of the canopy or the vigor of crops, and that can be used and processed into an estimate or a decent estimate of soil carbon changes. Third up is modeling. Modeling is the probably most widely used approach to MMRV. The challenge with modeling is that it doesn't require really much beyond a little bit of information on practices being done and the location. So the output is not really a measurement. It's a guess based upon measurements from other locations, theoretical systems of in agriculture, but it can't be used to say, what is the actual measurement of the soil and what is the change that's happening. And one of the problems there is that if you rely on a purely modeling approach, you could be undercounting or overcounting the benefits of the project. Next up is eddy covariance. And eddy covariance is a computational method that looks at the fluxes and the flows of gases in and out of the soil and the plant canopies and totals them up over time to show what the net ecosystem exchange is through the ecosystem. And it's a very powerful way to do it. The problem is it comes with an extremely high price tag, but is for precision measurement of changes in soil carbon and changes in carbon absorption by plant canopies, it is widely regarded to be the gold standard. Next up are soil chambers. Soil chambers can come and range in price from very low to very high. They use a controlled volume to measure the flux of gas in and out of the soil. That can include gases beyond just carbon dioxide, like methane and nitrous oxide. And they're a powerful way to understand the soils component of agricultural greenhouse gas exchange, but they are unable to sense the canopy absorbing CO2 directly. And then finally, there's the static continuous soil chamber system that Agrology developed. And this combines a soil chamber with canopy sensing along with machine learning to get some of the benefits of soil chambers and some of the benefits of eddy covariance, but without the typical high cost that comes with it. And so the foundation for any approach should start with ground truth measurement, which would be soil testing, eddy covariance, soil chambers, or Agrology's approach, and then layer on levels of remote sensing and modeling as necessary to balance cost with measurement across the project. All right, next slide, please. So diving into effective MMRV, MMRV means measurement, monitoring, reporting, verification. And so the first thing we'd emphasize here is measurement and monitoring fundamentally means ground truth data. If you aren't doing that, you're not actually performing an MMRV process on the project. The MMRV concept is measuring and monitoring and then passing that data up through the reporting chain to ensure project is reporting. Reporting typically means collecting and analyzing measurements so that you can convert that into a process to pass the project stakeholders. In this case, the farmers who are participating, USDA, and anyone else who is a stakeholder in the project who's interested in the carbon changes. And then, of course, finally, verification, which is typically a process used for auditing and attribution to make sure there's no double counting happening, or to make sure that the actual changes are real. That the verification process is based on the fact that historically a lot of these projects had very minimal ground truth measurement, and so some second layer of verification to make sure that what was happening was accurate was important. So, fundamentally, there should be a continuous process for MMRV, not just one measurement and be done, but to gather continuous data from these projects and then process them through the right models and the right reporting processes to succeed. So what we'd like to emphasize about MMRV on projects is there's a right way to extend measurement. And what that means is that you should not just rely on estimations as the foundation for MMRV, but to start with ground truth and then layer in models and remote sensing as necessary. Additionally, real-time data is incredibly valuable for these projects because they allow the participants and the project leaders to understand how the project is performing in real time, instead of just reassessing annually as soil testing is done, or potentially every 3 to 5 years. So real-time data will allow the participants from the farmers through the project leaders to modify the project to ensure the greatest degree of success and performance. Because of this, carbon flux measurement is an advantage over soil carbon measurements for a variety of reasons, ranging from the real time to the fact that carbon flux can provide more consistency across sites and is not going to be affected by any challenges related to variation in soil labs or sampling procedures. Additionally, a lot of projects have an emphasis on soil carbon, which can be measured by soil testing or carbon flux. However, there is a neglected emphasis on other greenhouse gases. And so, looking at nitrous oxide, looking at methane is really important to understand the overall performance of the project and how it's affecting greenhouse gases as well. Finally, the other thing we'll emphasize here is that we're looking at more, that we need to ensure that models that are based on ground truth data have multiple inputs. And what that means is that there's not just a single input to the model, a singular endpoint, because that can dramatically prevent it from understanding variation across the project. And then finally, of course, with models, one of the challenges is that the impact of a small variation in carbon in the soil, a few percentage points, can be a massive amount of tons of carbon. And so the error margins on models can be the difference between having 5 or 10 tons of project performance of carbon sequestration or 1 to 2. And that is a significant impact, especially when farmers' revenue is potentially on the line through participation in carbon credits. So the challenge on this project in particular was that we were looking at not just one uniform area of terrain. It's not a Midwestern corn soy rotation state. It's not a mountainy cattle rangeland state. It's not a specialty crop area. It is a huge amount of variation across the island of Puerto Rico, ranging from dry areas to very wet areas, from lowlands up into the mountains. And so this presents probably 24 microclimates that need monitoring and compensation. And so that was a huge challenge to the project, and it led us to push for more ground truth measurement. Next slide, please. And so the approach that Agrology did as a participant is to look for how we can deliver gas flux measurement in an affordable way for the participants in the project, and to do that across the varying ecosystem that we see in Puerto Rico. So we are deploying over a dozen monitoring devices across the project to ensure that the varying performance of the participant farmers is captured across the varying microclimates, and to also to measure that impact directly on site, be able to attribute it back to specific growers, and to not just say with the model that this is we estimate the performance of the project. And so that data we would like to have been able to do it across all the project participants, all of the farmers, but they're simply too large a volume. So we pick representative farmers and represent different parts of the microclimate systems that we're looking at to capture the variation in the environment across Puerto Rico. Next slide, please. Excuse me, next slide, please. All right, folks, my screen may have gotten stuck here. Can someone please let me know if we moved on to the next slide?
Yeah, Adam, we're on the second agrology approach to MMRV slide.
Thank you. Sorry, folks. Let me just see if I can refresh that here. I'm going to just pull it up from my hard copy here. One moment. So our focus at Agrology is looking at really low cost affordable gas measurement. And the reason we like that is it gives an accurate measurement along with soil health changes, soil carbon, and greenhouse gas emissions. It also works reliably across various conditions. There's no sampling of soil, there's no transport of soil that can affect measurements. And most importantly, we believe, is it empowers growers to quantify and monitor the real outcomes of their farming practices in real time, and then not let it go and close the loop on how practices connect to outcomes in a climate smart commodity project. But ultimately, the challenge we've identified, as we've mentioned, is that we couldn't deploy enough devices with the budget we have across all the participant farmers. And so at this point, I'm going to pass the microphone over to Josh so we can talk about how Praedictus takes the agrology and then extends across the areas that are not directly monitored by agrology devices. Thank you, Josh.
Thanks, Adam. All right. Yeah, well, I'll go ahead and pick up here. So as I mentioned in my intro in the beginning, the core thing that we do at Praedictus is biophysical crop modeling. So we have a proprietary platform that actually leverages open source models such as the decision support system for agrotechnology transfer. So that's DSAT, one of the most commonly used, widely researched, well-developed crop models is out there. We also use some other models as well. But essentially, at Praedictus, our core competency is deploying these models flexibly at scale across a variety of environments, a variety of spatial and temporal scales, on a variety of data, whether it be sort of standard weather observations or more like climate model data, and being able to do that in a commercial capacity or in a sort of bleeding edge research capacity. So that's what we do as a company. And our goal is, of course, in this project, as Adam mentioned, is really to extend the measurements that we're doing on the ground, both in terms of the sort of conventional soil sampling measurements, which give us some basic baseline information, can be repeated every few years, but also very critically, the real-time measurements that Agrology's Arbiter devices allow us to capture. And so really, right, when we talk about extending measurements, it's both extending them spatially and temporally. Again, as Adam said, we can't put devices on every site in Puerto Rico or Florida. We can't even do conventional soil sampling on every site in Puerto Rico. So we need to use the modeling constrained by the observations that we can take in order to draw inferences across, because we want to be able to draw some inferences across all the 100+ farmers that are participating in Puerto Rico and 50+ farmers that are participating in Florida, which again is one of the really great aspects of this project, the broad-based participation we have, and we want to be able to provide useful information and believe we can provide useful information to every single participant in the project, even though we can't do soil testing and real-time measuring on every single farm, right? So that's one point. I think the other important point to make about modeling, right, is that, from a practical perspective, we need to be, these are ultimately, we're looking to facilitate financial transactions based on environmental assets that are accruing based on good climate smart management practices. And we need to be able to look forward a bit, at least make some forward inferences in time, again, grounded in measurement, but extended by the modeling. And to do that, you need the modeling to be able to at least give some order of magnitude of, okay, well, what is at least reasonable to expect in terms of, say, increased carbon storage or decreased nitrous oxide emissions over, say, a 5 or 10-year time horizon. And of course, we can do that quite quickly with the models and explore different scenarios. And this is, I'm not an expert in the marketing side. That's what Dom will get into in a minute. But of course, this is really important for just sort of getting things off the ground as a practical matter of providing some information in orders of magnitude around what a potential project could yield. And so that's another really fundamental role for the modeling, sort of marketable projections is one way you could start to think about it. Now, before moving on too much further here, I also think I probably jumped ahead a little bit because just talking a little bit about the models that we're deploying, I've referred to them a few times as biophysical crop models. And, what does that mean? Well, what that really means is a mathematical representation of how any plant grows. In this case, we're looking at forage systems. So you think, grasses, Bermuda grass, Bahia grass, these types of forage crops. And what these models do is represent how they grow in interaction with the soil, with the weather that they're experiencing, with the management practices that are being deployed. And so we can represent all of those explicitly in the model. And then the model goes through, sets of fundamental equations to simulate various aspects of the system, whether it be carbon storage in the soil, biomass of the forage being produced. And we can look at all of these things under different scenarios and make inferences about them. So an important aspect to understand here is that these are ground up biophysical models, meaning they are built on first principles of chemistry, biology, physics, agronomy. They are not, this is in contrast to like the statistical model where you need observational data to have already been collected in order to do any calculations or draw any inferences. So it's a particular class of model, which I think is really appropriate and really the best modeling tool in this particular context. So finally, just sort of to wrap up my points here, again, the role here is really to be able to gain some rapid insight in what can happen across the kind of broader spatial and temporal scales, so looking forward in time, looking out through space across the island of Puerto Rico and in Florida. And really, again, to emphasize the point that Adam has made a number of times, the modeling here is not meant to replace measurement. It's really meant to complement and work in concert with the measurements. So we're using the measurements from the Agrology devices and indeed from some of the physical sort of traditional soil lab testing that we're about to do, to constrain the models, to calibrate them, to validate them, and to do extension and interpolation, you might call it. But clearly, like as Adam again stated multiple times, being able to do the measurements is really the foundation, and the modeling really extends that. So really important point to understand. And yeah, I think we can go ahead, and I think we're passing it to Dom at this point, or is this one back to Adam? I'm not sure.
I think it's me.
That's
Yeah.
it. Okay.
Awesome. Well, I'm gonna start with really kind of doing a little introspection and posing a question. And today I'm personally thankful we live in a world where there's increasing demand and value for environmental attributes in agricultural systems. But with increasing demand comes increasing complexity, and we need better, more sophisticated systems of reference to really lower the frictional barriers, reduce systemic risk, and increase the value for the outcomes the producers who are leading the transition to climate smart agriculture are creating. Next slide, please. So there's a lot on this slide, and I'm not going to kind of go through the steps, but I'm just going to articulate the main takeaways. So we at MillPont are creating a common language and data framework for trading, tracing, and sharing value in agriculturally focused ecosystem service market initiatives, such as this one. This includes Scope 3 programs, biofuels, and sustainable sourcing. We're collaborating with some of the leading environmental market pioneers, the project developers, food companies, and certification standards to really break down data silos and mitigate double counting across platforms, while providing a unified system of reference to help everyone operate more efficiently and effectively. So we're really achieving this to date with our geo-intelligent claim IDs. The process below, as I kind of highlights the critical steps that to request, create, issue, and manage what we call a GCID. And leveraging GCIDs fosters more systemized trust and confidence, and helping stakeholders operate more efficiently while reducing operational and systemic risk, and bolster confidence in these really imperative environmental market mechanisms. So with the GCID, we're creating a portable, secure certificate that can offer optionality for monetization pathways and complement the existing ones that are out there today, and connecting them to a shared data exchange system with a one-click chain of custody auditability. So by design, our system and services protect privacy while promoting cross-platform transparency. And we believe this is really important as we're all kind of in this nascent stage of the market, developing different ways and experiments on how to maximize impact and provide value for the benefits that producers are creating. And at the end of the day, we're creating what we hope is a system-wide transparency, and that'll be grow as our user base and the operations of existing users grow as well. So just kind of where we're at today since launch, we're in 2024. We're onboarding about 1 million acres a month, and it's a privilege to be in one of a system like this in agroforestry with small stakeholders, but it's also just to demonstrate the variability of agriculture. We can also operate and are operating across row crops, grazing grasslands, agroforestry, perennial tree crops, and biodiversity projects on 3 continents. So this is particularly exciting that with this project, we can show that this infrastructure operates regardless of the size of the stakeholders, and brings them a way to access these new markets that we are really personally and professionally bullish that are going to be the standard of tomorrow. So that's what we're doing, and excited to dive in more on how this all operates it within a market framework in the next presentation.
Thank you, Dom. And yeah, that next presentation is going to be really interesting. I think that, ultimately the purpose of MMRV is not measurement for itself, but we look at it on this project as a way to make this project sustainable beyond the period when USDA is supporting it. And that's what's so exciting about being a participant in this great project, is that we think we've identified the partners to hopefully make that feasible. So the next slide, we want to show some preliminary data that explains what we expect to see on this project. The first slide here is daily carbon flux from one of our sites. We see flux growing across warmer months, and this is an example site. This flux is an indicator of a healthy soil biome, which is soil that can capture more carbon. And so this flux represents the respiration of the soil microbial biomass primarily. And so in the next few weeks, we will go and be able to release the ability to convert this flux into the equivalent soil carbon biomass based on these measurements as we finish up the development on that capability. And so seeing, the power of that gas flux, it provides more than just the flow of carbon out of the soil, but insights into the vitality of the soil and how large the microbial carbon biomass is. Next slide, please. The challenge with some of the soil science that we look at with our systems is that it cannot be easily comprehended by growers. So we will process that data into other things like the soil health index, which is the same data, but simplified so that growers can glance at it and get a quick insight into their soil health over time. It's simplified in the way that it's going to normalize it across variations in soil temperature and soil moisture, so that growers and farmers will be able to see the trends overall without having to worry about a given day's or a given week's varying conditions, which will let them go and see how their cultivation changes across seasons are affecting soil health. Next slide, please. All right, so to wrap up here, we want to go over again one more time the best practices for MMRV. So first off, ground truth foundation, as I've emphasized, it's a bottom-up approach. It's really important to know what's actually happening before you do any models and extension. Ground truth is also critical for understanding other greenhouse gases like nitrous oxide. It ensures the highest possible accuracy. The key thing is finding that balance between cost and scalability. Next up, real-time data is really critical on these projects. They're relatively short for a agricultural ecosystem, so real-time data will just let project participants at all levels understand what's happening and build better. So any modeling should be built on top of ground truth data and not just a singular point to ensure the highest quality. And then finally, it's important to take the data and find ways to ensure it is easily accessible by buyers of environmental assets, and that those buyers are confident that it's high quality and can be audited, and that there's market infrastructure to connect the buyers back to the MMRV data, and most importantly, to the actions that farmers have taken to create a healthy, robust marketplace that rewards the farmers that are doing the work. Next slide, please. All right, and so on the next webinar, we're going to discuss how we can drive value for environmental outcomes, which is really, really critical for making these projects sustainable beyond the period when they're supported by USDA, how to turn data into environmental assets, how quality MMRV differentiates and adds value to environmental assets, how we can create opportunities and access for even small stakeholder farmers in the digital ecosystem, equitable access that doesn't necessarily exist in traditional systems where there's huge barriers to participation, and then finally the monetization pathways and price discovery for the environmental assets that project participants will be receiving. I also want to call out for any product updates. Please go ahead and visit Victus, Puerto Rico. And before we get to the last slide of context, we're going to take a second here and cover the questions that we've received. So I'm going to pull those up now, and I'm going to pass them out to the general participants. So it looks like the first question is from Jason Gale, who says that he still doesn't understand how weekly carbon flux will give long-term carbon sequestration. Love the project, not sure how the initial data flows to that long-term outcome. And so, Jason, what I emphasize here is that their long-term carbon sequestration may be somewhat outside the scope of this project based on the initial timeframe USDA is participating in. But ultimately, what we want to see is by using carbon flux continuously, and I'm sorry, it looks like the name is Jason. It's actually Erica. Sorry, Erica. Looks like she's using another Zoom account. So we look at the changes in flux over time to see net in, net out to understand permanent carbon storage. And that's really a key thing to emphasize, that that you have to continuously monitor projects to see if that carbon storage is permanent. Over time, there are biological mechanisms and chemical mechanisms that can take carbon in the soil and mineralize it, but ultimately it's continuous monitoring that allows you to understand this. Additionally, that flux is really just going to be the best way to understand, the immediate changes, the fast changes that farmers can do as they influence soil health and ideally increase the size of the soil microbiome. But then, of course, the long-term goal is fostering that soil microbiome to keep the carbon in the soil and allow pathways for mineralization to happen. So I think it looks like, Erica, all the questions came through from you. And I want to say, at this point, are there any other questions from the participants? All right. So the last thing I'll say here is, before we get on the concluding slide, is that one of the challenges we've seen across Climate Smart projects is under emphasis on actual measuring in the approach, or just reliance on the traditional large models like Comet or Descent that are were built for academic purposes or for general guidance, but not enough investment in ground truth measurement, specific project modeling based on ground truth measurement, and high quality. And so what we're hoping to see on this, with this webinar and with the follow-up webinars, is the opportunity for more high quality measurement, reporting, and verification and monitoring to happen across these projects, as we show ways for this process to be affordable and scalable and rapidly deployable on USDA Climate Smart Commodities projects.
And Adam,
all right, I think at this point we can roll on. Oh, go ahead.
Oh, I was just going to make one off the cuff comment, and so hopefully I don't get myself in trouble. But I think for the benefit of those who weren't on the first webinar, I think it's also really important to emphasize one of the foundation for all of this is having truly engaged participants. That was the topic of the first webinar, but really that goes to, okay, you need folks who are willing to be engaged in doing the measurement, who are willing to provide information so that we can make meaningful models to extend the measurement, and who are also then going to be engaged in actually, getting on a market platform and marketing the asset. So it's our job as the team, the collective sort of MMRV team that sort of presented today. Like, it's our job to put all the data together, to make it transparent, to do the measurement. Ultimately, as in the next presentation, you'll see from Dominic, to provide a marketing platform. But we provide all of that. But what's really key is having participants who are truly engaged and on board to go through that whole process, because that's where you really see meaningful, demonstrable outcomes. And so I think one of the differentiators of this project and this team that's here is sort of all going through that process together with a really great group of engaged farmers. So, I just wanted to, because they're really informing everything. It's all starting from the bottom up in terms of their agro ecosystems, are informing everything that we're doing on the MMRV side.
And there's a couple more questions, I think,
Thank you. Yeah,
towards
I'm
Josh and
looking at
Adam. I
them
can
now.
read them all. So
Yeah, no, I'm
Michael
pulling them up
asks,
right now. Thank you, Dominic, and thank you, participants.
can you talk about accuracy of models versus real world measurement?
Yeah, and I think, Dr. Michael, that's a great question. The challenge here a little bit is that this project is not operated long enough where we can, compare the models that we're generating for this project to the ground truth measurement. But in general, models are probably better than nothing. But if you look at things like, model says its estimate of soil carbon is within, 10% of accuracy, that can be tons per acre. So it's hard to comment on the accuracy of models specifically. And one thing I think we'll, look to see on this project is they'll be able to get, some good output data on that. And it's something we'll have to inform with, the outcomes with over time. Other than that, it's hard to say beyond the fact that a model without any ground truth component is extremely unlikely to exhibit any accuracy because of the fact that it's lacking ground truth data. And I'm solely looking at it from the perspective of soil carbon. When you're considering things like nitrous oxide emissions or methane that are temporally variable, depend a lot on things like soil moisture and when cultivation practices like fertilizer applications or irrigation happen, it can be almost impossible to model that because it's so dependent upon the combination of environmental variability and the varying practices that farm doing. So we'll have to circle back to that question in a few months when we have more data streaming in from the project and we can answer it. And it'd be great to go ahead and look and say, like, we'll look at the variation accuracy of ground truth data versus models built on ground truth versus models just based upon reported cultivation and get a better sense of how much error is captured in a model only approach. The next question I see is from Eric Foster, who wants to explain the calculation from flux to microbial biomass and how we can root respiration. And so, this isn't something where we are developing our own. We're actually relying on a series of papers published by a number of soil scientists who related soil microbial biomass to soil respiration in a huge variety of soils across the United States. And so we use those empirically developed equations to relate respiration back to soil microbial biomass. And those relationships account for root respiration intrinsically in how they look at the relationship between soil microbial biomass carbon and soil respiration. And we'll be putting out some white papers on that in the very near future. But if you'd like, Erica, we can send you over the papers that we're referring to. Then, sorry, and that was Erica Foster. I have questions from two Ericas here. I have to keep track. So Erica Luffing, who is not Jason Gale, has another question, which is it cheaper to do carbon flux or measure carbon soil content a few times a year? And that's a tough thing to say. It depends on how accessible a site is. It depends on how cheap labor is to do that soil processing in a lab. It depends on what soil carbon content tests you're doing. And so, I think the question there would be, you really have to evaluate it. The advantage to Flux is that it's reported automatically and digitally continuously. So the data is coming in. And you don't have to go out and do that additional work because we're talking about some sites that are not necessarily super accessible. And on some Climate Smart Commodity projects could be extremely remote. So having data automatically is highly advantageous. Soil sampling, at its most basic level can be a very affordable approach to ground truth MMRV. The challenge is that by the time you look at, high quality measurements, several different approaches to understanding soil carbon, looking at soil health, things like respiration test, it adds up quickly into, a couple $100 per test. And so multiple tests plus travel, so forth, can probably exceed the cost of carbon flux pretty quickly.
Right. And I would also just say from a sort of a softer side of it as well, the ability to engage folks with the data on a real-time basis, I think is going to be really important. So like, the fact that we'll be able to take that data through the Agrology API, process it into a interpretable output, provide it to the participants on a real-time basis is going to be, I think, a very, very important tool for engagement versus just getting some static test results once a year or even a few times a year. It's yet another tool, aside from sort of the pure measurement science cost aspects of it. It's also it can also be used as an engagement tool, and I think that's really important as well.
Thank you. Thank you, Josh. I have another question from Erica Foster, who was curious about how the data is reported to farmers and if raw data is shared with producers as well. And so the challenge here is this: like, raw data can mean a variety of things. Flux is calculated off a huge number of measurements. So we can share Agrology, we can share all of that data, but it's not necessarily super meaningful to the farmers. We allow the farmers to have access to data in the grower portal. We allow them to have access to data via static PDF reports. Connect there for a second, which was the next point I was going to make, is some of the growers work in areas where high levels of broadband access is
We might have lost Adam,
I
guys.
think hopefully some
looks like
part
we have
of my
Adam back, at least for now.
Okay, what I was saying, and hopefully this will come through, is that one of the challenges on this project is that not connectivity, and you can see what a challenge it is to use digital tools when you have connectivity problems like I'm experiencing right now. And so we're going to have to evolve the product to make sure that data is accessible to all participants. And then the last question I have here is from Grant Bode, who says, perhaps I missed this, but how are you identifying / breaking up the various microclimates? That's a great question, and not one that I'm able to answer. If there is someone from Victus or Manuela who can cover how the microclimates are identified, that would be fantastic, please.
Edwin would be the guy to.
I was being kind and
Yeah, I just
letting
realized that
Indio
Edwin
take
would
that
be the
one.
guy.
So Indio could probably chime in if you are connected, Indio. Let me share just some data on the selection process. Obviously, we have identified regions where there is a high number of pasture land on the island. The island is divided in districts, and we also know that there is areas where we have individuals like Edwin Mas, who was mentioned, that have a long-standing connection with these farmers and these growers, and many of them are in areas where it gives us an opportunity to measure differences where they are identified. And then also we look at data from NRCS, ProTrax data that show number of participation of these growers, not only in Puerto Rico, but in Florida. Besides that, there is additional measurements that are taken or evaluations that are done at the level of the intake outreach. And then from that moment forward, there are a number of different techniques follow, randomized numbers of areas that are going to be selected for measurements, depending on negotiations with the folks that are actually here doing the MMR.
All right, thank you. So let me see if any other questions have come in here, and we can follow up a little bit with that if you'd like. It was an impressive history of agriculture in Puerto Rico and climate division, and it was also really emphasized to the rest of the project participants how critical ground truth data was going to be. So I think that covers all the questions we have. And seeing as we're almost out of time here, I want to take a moment to say that we'll be in touch to all participants with the next webinar in our series that's upcoming soon. And we look forward to having you participate again. And please feel free to forward out the invites to anyone you think might be interested. The only thing I'll say is it'd be super awesome if they could register on their own, so that I don't end up calling any more Erica's Jasons. So thank you, everybody, for your input, and thank you for the project leads for putting together such a great project, and for the rest of the participants today for sharing the insights on successful MMRV for Climate Smart Commodities projects.
Thanks, everyone.
Thank you.